Hello everyone. So in the last video, we I showed you how to get the coordinates for any NACA 0012 airfoil or any airfoil using the website called as airfoil tools. Now in this video, we will be reading the coordinates from the text file and we will be creating the geometry for the airfoil. So in order to do that, first thing which you have to do is you have to load the workbench. So it is very easy to load the workbench. Just go to your search tab and type workbench. You can see I am using ANSYS 2023 student version, but if you have any other version, the process will remain almost same. There will be a little bit difference in the interface, but you can use any ANSYS version software, whichever is available for you. Now I want the first thing which you have to do whenever you are doing any CFD simulation or any kind of project in NC Fluent is save the project. Because if you forget to save the project, what will happen in between? Let's say if something let's say your computer get stuck or something, there is a chance that NC Fluent may crash. So in that case, you will lose all the progress. So the first thing is we will save this project. So I will go to File, Save As, and I have created one folder called as tutorial for this video. So I will be saving my file here. So let's say NACA 0012 simulation. You can give whatever name you want to. So now you can see the status here on the left corner and you can see it is saving project. Now it is ready. So now I want to do simulation using ANSYS Fluid Flow. So you can see it is here. So I want to open this project or load this project. In order to do that, you can either double click it or you can drag and drop it here. So now you can see our Fluid Flow Fluent project has been loaded. If you want, you can give any name. So let me give it a name as NACA 0012. Now, what I want is, as I mentioned, we are going to do a 2D simulation. So the first thing which you have to do is you have to change this analysis type from 3D to 2D. It is possible that you won't see this option. So your workbench will look something like this. So in order to get that option, what you have to do, go to geometry, right click, and then you can see here we have this properties. So click on that property so you can see this property menu came up. So in this property menu, make sure you change your analysis type from 3D to 2D since we are going to do a 2D simulation, and then right click on geometry. So you have different options in ANSYS Fluent. You can create geometry using discovery, space claim, design modeler. So in this video, I will be using design modeler. So just click on design modeler, it will load. So you can see the status on the left hand side, starting design modeler. So it will take a little bit of time. So let's wait for the design modeler to get loaded. Now you can see our design modeler has been loaded. Now the first thing which you have to do before you start designing any geometry in design modeler is you select the proper units. So if you remember, I got the coordinates of the airfoil, and if you remember, the x coordinate is 1, y coordinate was 0, z coordinate was also 0, and all those units are in meter. It means the chord length of my airfoil is 1 meter. Now, what is chord length? Chord length means when you draw a line from the leading edge to the trailing edge of the airfoil, so the length of that straight line is called as chord length. So most of you already are aware of it. So in our case, the chord length of airfoil is 1 meter, and the domain which we are going to create around airfoil is gonna be in meters. So that's why I will select the units to be meter, which is pre-selected, but still you have to make sure that units are meter. Now the first step is, after selecting the units, we want to read the coordinates from the coordinates file which we created in the last video. So in order to do that, click on concept, go to 3D curve, and make sure your definition is from coordinate file, because we want to read coordinates from coordinate file. Then click on coordinate file, and then you have to browse where your file is. So I have saved my file in the desktop in a folder named as tutorial. So you can see here NACA 0012 coordinates. Then click on open, and coordinates units are meter, and my base plane is XY plane, and operation is add material. So keep all the other settings as default, and then click on generate. So you can see my airfoil has been created. So right now you are unable to see it because it is very small. So in order to do that, what you can do is you can click on this option called as zoom to fit. And the shortcut for this option is F7. So if you press F7 in your system with your from your keyboard, you will see the airfoil. You can see this is my airfoil. Now next what we have to do, we have to create the surface from this airfoil. So in order to do that, go to concept, then click on surface from edges, and just select this airfoil, click on apply, then click on generate. So you can see your airfoil has been created. One more thing which I will suggest is, as you create something, make sure you give the name, because when you create some geometry or something using lines, planes, point, so later if you want to make some modifications or changes, it becomes very difficult for us to recognize which plane represents what, which line represents what. So I will suggest you to give names along with that. So like, I know that this surface body is my airfoil body. So I will rename it as airfoil surface. And this line body is my airfoil, is related to airfoil. So I will name it as airfoil boundary. And this surface is also airfoil surface. If you want, you can name it airfoil surface. So since we have already used that name, so it gave airfoil surface 2, and this is airfoil curve. Airfoil curve. So now we have created the surface using airfoil. The next thing which we want to do is we want to create a domain around the airfoil. And in this case, we will be using C-mesh domain. Now, what is C-mesh domain? C-mesh domain is a domain where you will be having a rectangle at the uh, towards the trailing edge, and in the front part you will be having a curve. So how will you create that? So to create that, click on XY plane, because our airfoil is on XY plane. So we want to create it, and then click on this option, which is new sketch. Now go to sketching, and before starting sketching, make sure your auto constraints are on. Auto constraint means when you create a horizontal line, it will show H. When you create vertical line, it will make sure that line is vertical and all those stuff. So go to draw, click on rectangle, and first let me create a rectangle. Now I want this rectangle to be symmetry about this x-axis. So I will go to constraints, click on symmetry, then first click on axis of symmetry. If you are unsure what you have to do, you can see on the left side, bottom left, it is showing. Select line for axis of symmetry. So this is my axis of symmetry. Then select the edge. So first edge, second edge. So you can see now this rectangle has been is symmetry about this x-axis. Now I want to give dimensions. So I want to keep this rectangle at a distance of 0.1 meter from the leading edge. Why 0.1 meter? I am just taking a kind of like approximation. If you want, you can keep a little bit below, little bit like below towards the right side, towards the left side. It's totally up to you. Other than this, I want my length of rectangle to be 25 meter, and I want the width of my rectangle to be also 25 meter. So you can see, okay, wait, I want my horizontal distance to be 12.5. So again, how I am getting this numbers 12.5, 25? These are the numbers which you have to play with because the size of the domain also plays a very important role when you do simulations for airfoil. So first you will decide some values, dimensions for the domains. You will run your simulation. You will look at the results. If you get the desired results, it's good. If not, then you will increase the size of the domain periodically till you get the desired results. Now after this, what we have to do is we have to create a arc in the front part. So I will click on arc by center. And if you see, I'm zooming in. How I'm zooming it? I'm just creating, clicking on the, clicking the right mouse button and then creating a kind of box around the region where I want to zoom in. So I want to create an arc and the center of the arc should be the location where this rectangle is intersecting the x-axis. So just select this point and then zoom out, select the next point of the arc to be the edge of this rectangle. And as you see, as you move your point closer, it will show P. P means it is the point where my rectangle edge is. So click on this and then here again it is showing P. So click on that. Now you can see your arc has been created. Now don't want this rectangle, this edge. So we need to trim it. So go to modify, trim, and then you can trim this edges. Now if you see, I haven't given any dimension for this arc because I know the center of the arc is this x-axis and its radius is equal to half of the width of the rectangle, which is half of 25 meters, so 12.5 meters. So the radius is obviously 10.5 meters. If you want, you can check it by using dimensions and all, but I will not do it here. So now we have created the boundaries for the domain. The next step is we want to create the surface using this sketch. So to do that, go to concept, surface from sketches. This time sketches because we have created a sketch. And coming to base object, so you need to select all these curves. So in order to select multiple curves, select one curve, then press Ctrl in your keyboard and then select rest of the curves. So once you have selected all the curves, you can release the Control key and click on apply. So you can see one sketch has been selected, and make sure you change your operation from add material to add frozen. And the reason for this is if you create add material, ANSYS will combine the airfoil surface and domain surface and give you one single surface, which we don't want. We want airfoil surface and domain surface need to two different things. So that's why we are keeping it as add frozen and then click on generate. By the way, the shortcut for generate is F5 key. So you can use either F5 key also from your keyboard. Now you can see I have two different surfaces. One is my domain surface and one is my airfoil surface. So you can see this is my airfoil surface and this is my domain surface. So I know this surface is domain surface. So I will rename it as domain, and if this surface is related to domain, so I will name it as domain surface. And this is sketch I have used to create the domain. So I will give domain sketch. Again, you can give whatever names you want. So now our domain is also created. The next thing which we want to do in order to create CMS domain for airfoil is we need to split this domain into different surfaces. So how we will do that? So in order to do that, first what we will do is we have to divide this domain into two equal halves. So if I show you, so what I mean is, so this is my domain and I want to divide this complete domain into two different halves. This top one should be my first surface and second one should be my second surface. And how will I do that? I will be able to do this if I create a plane like this. It means XZ plane. If I create an XZ plane, so this XZ plane will be able to split my domain into two equal halves. So again, here I am splitting using the planes, but there are other ways also by which you can split your geometry. Like you can create lines and then you can project that lines on the face and then you can split it. But I find this splitting using planes a little bit more time saving. So that's why I'm going with this approach. So as I mentioned, what we have to do, we have to first split this entire domain with the help of XZ plane. So what you will do, you will go to tools and then you will select this option face split. Now remember we are splitting with the help of planes. So make sure your face is split type should be plane. Now what is your target face? My target face is this one. And what is your target geometry? Your target geometry is XZ plane. So click on apply and click on generate. So now you can see my domain has been splitted into two surfaces. Now next what I want is I want to create one more surface and I want to create one more, split it into two parts. So that for that I need to create an an YZ plane. So how will I create a YZ plane? So first you will and that YZ plane location should not start with the trailing leading edge. It should be at the leading edge. So what I will do, I will go and click on this option called as new plane and I will give the name of this plane as trailing edge plane and make sure your type should be from plane. Sorry, not from plane, it should be from coordinates because we know the coordinates of the trailing edge. So we know the coordinates of the trailing edge is it is at 1 meter and since we are creating a YZ plane, so the normal should be x. So I will put 1 in place of x and 0 in place of z and rest of everything we will leave as it is and then click on generate. So now you can see I got one plane which is at the trailing edge. Now what I want is I want to just split it using this plane. So again, go to tools, face is split. Make sure your face is split type is biplane. Your target face is these two plane. Again, to select multiple planes, click on use control key, then click on apply, then tool geometry. So which is our this plane, the plane which we created just now, that is our trailing edge plane. Click on apply and then click on generate. So you can see now our geometry has been divided into 4 different planes. Similarly, I will create one more plane which is at 0.1 meter from the trailing edge, from the leading edge, and I will repeat the process. Again, new plane. So name of this plane is, let's say, leading edge plane. Again, type should be from coordinates because we know the coordinate. So x coordinate is 0.1 meter. And again, the normal is x because we are creating YZ plane. And then click on generate. Again, go to tools, face is split. Make sure split type is by plane. Target face is this one and this one. And tool geometry is leading edge plane. Click on apply, click on generate. So now you can see finally we have divided our entire domain into 6 different planes. Now one thing which we forgot to do is we forgot to subtract our airfoil from the domain. Because if you know, if you remember in CFD, whenever we do simulations or whenever we do an analysis, we always subtract the geometry from the domain. So we forget to do that step, so we'll do it now. So in order to do it, go to create and click on this boolean. So we want to subtract, so make sure your operation is subtract. Now you have to select 2 things. One is your target body and one is your tool body. Now how will you get to know what is your target body and what is your tool body? So remember, tool is something which you use and then throw it. And target is something which you want to keep it forever. So in this case, we want to keep the domain. We don't want to keep the airfoil. So our target body will be domain and our tool body will be airfoil. And then click on generate. So you can see our airfoil has been subtracted from the domain. So now we are done with everything. So at last, what you have to do is you have to suppress all the line bodies. We don't want to keep the line bodies, otherwise they will create uh, some confusions in during the meshing and all, which we don't want. So make sure you suppress all the line body. So you should always make sure in CFD that you should have one body in the parts and modules. And then your domain, you can see right now your domain is solid. So make sure to change it into fluid. Even if you forget to do it here, you can do it later also in setup part, but it's better to do it now. And then click on generate. So you can see now our geometry has been created. So in the next video, I will be going through the meshing. So see you in the next video. Thank you.